This is the series of design pattern. Let's see the third category of design pattern, that is behavioral design pattern. Behavior design pattern focus on communication between two objects, how they interact with each other, how they assign the responsibility between each other, and how independently they interact so that they being loosely coupled. Main focus of this design pattern is to communication between two objects. Let's see the different type of behavior design pattern one by one. First, chain of responsibility. It says that whatever the object has, if object not able to handle it, it passes to the other object in order to handle it until it completes the handle process. We can see this in example of customer support escalation. In any e-commerce website, whenever you do order and we have any issues regarding our order, then we communicate with the customer, and the customer we whom we communicate, it's a lower level customer. If it's not able to solve, then he passes to its senior level. Similarly, we can handle it with a code. You can see first class we have for handler, and then we have for low level. If request is less than 10, then it handled by the low level. If request is more than the 10, then it goes for the higher level. If I run it, it will be printing for higher level handle. If I change the value to 10, then it will be handled by the lower level. Let's see the second one, which is command. It says that encapsulating the request as an object, allowing undo and redo operation. What is mean by that? So let's understand with example. Consider you have one remote control and you want to operate operation on using the remote control, like lighting turning on off and on. With a single command you can perform both the operation, which is once you turn on it means redo, and if you want to off you press the same button, it will be turning off. So we can create one more class for light turn off. Now here I have light turn on, so if I run it, it will print light on. Let's see the third type, which is iterator. It says that whatever the elements you want to have and you want to iterate those elements, for iterating we can use this iterator. So iterator are very common in the programming language. We can utilize many inbuilt iterator like collections. Here we have, if I run it, I will be getting all the number one by one. So I am having the three ABC character, I am iterating one by one. Fourth one is mediator. So mediator, as the name says, that it's a middleman. So whatever the communication if you want to establish between two system, and for communication between two objects, you want to have one middle person so that the communication is reachable to everyone. So you can understand with a chat room example, like we have many chat room. We have WhatsApp chat room where we create one group and we uh, send our message so that everybody knows what the other person is saying. So similarly, this example we have, there is a user. So consider there are user 1 2 3, and here you can see user 1 send hello, then it reaches to the 2 user, which is user 2 and 3. If I run it, it will print 2 times hello. Let's go for the next one, which is Memento. It says that capturing and restoring the object previous state. It is also example of feature where we want to store the previous state in order to move back whenever we want. So it is very much famous in case of document we are writing. So if you have any document you are writing and you want to modify any text which you have written already, so you perform the redo operation, so undo operation basically. So here this is being handled with the help of this design pattern, which is Memento. If I see, I have one editor, which example I told. So I had first initially set the version 1 and save that version, and after that I try to set the version 2, and then I call the restore version. Whenever I call, it will revert back to the previous version. If I run it, it will print the version 1. If I don't call restore, then it won't. So this is how we are storing the history of the field, and we call whenever we want. Let's move the sixth one, which is observer. It define one to many dependency. So when one object change, other are notified. It's nothing but the notification which we get, like we get notification from YouTube subscription, we get notification from WhatsApp messages. So similarly, the notification are very famous concept which use in very one of the famous tool, which is Kafka. There's publish subscriber is there. One person is subscribing and another is publishing the message, which is very much similar here. Now I had a price update which is 100. I had notified to the subscriber. Let's move to the seventh one, which is state. Allow an object to change behavior when its internal state change. What it mean? Let's understand with the ATM machine state example. Consider you went to the ATM machine for withdrawing cash. So in the process of withdrawing, we follow certain step. Like first we insert card, and then we follow certain steps on the machines. Like we enter amount to withdraw, and we also select button to go to the next. So the same select button which will perform different action based on the state. First you perform to enter your amount, and then you perform for enter your password. Same button you perform means the same button allowed to perform different state based on the situation. So this is very similar to that. So initially it worked for the start state, and then also I used for the stop state. Same button. Let's go for the 8th one, which is strategy. It defines the family of algorithm and make them interchangeable. So this we can understand the simple example of a payment method. So in any e-commerce website or any website where you do the transaction, so we usually get many different types of transaction method. Like we get UPI method, card method, or also we get cash on delivery type of method. So similarly, this can be handled with this strategy method, which allows to organize the family of algorithm, like similar kind of uh, family in a certain pattern. If I run it, it will print the UPI method paid by UPI. If I call other one, it will display the card method. Let's go to the next one, which is template method. So as a template said, it helps to define the skeleton of algorithm, and it's usually used to override the steps which we have defined in the parent class. It is nothing but the parent child relationship, whatever we have defined in the parent, and we want to invoke or we want to modify from the child, so that we can utilize these techniques. Here I can show there are different methods we have defined, like select items, pay, delivery. And in the child class we have overridden the select item and the pay, and when I execute it will print all because I have defined call all in order. So it first select item, then pay, and then deliver. Let's go to the next one, which is visitor. It separate the algorithm from the object. What it mean? It allow to segregate the actual function from the function on which it want to depend. So for example, we can understand with this example. Consider there is a different function we have created for different objectives. First, like with liquor, necessities, this kind of object we have created. Now we wanted to calculate the text for different object. In that situation, we have to call this function in each text function in each classes, which is very difficult to achieve, because if we want to modify certain uh, thing in the text, then again we need to modify in all the classes. In order to make it independent and make it loosely coupled. We can define separate class which is text visitor, and whatever text related thing we want to modify there, we will keep modifying there. We didn't touch the other class, so that it is loosely coupled and help us to modify very fast. It also serves the property of open for extension and close for modification. If I run it, it will give me the items which we had defined here, like calculating the tax for liquor and tax for necessities items. Let's go to the last one, which is interpreter. So interpreter, it is very rarely used. It is used when we have very small concept expression defined, and we want to define the expression for a certain category of languages. For example, we have a numerical expression where we want to perform different numerical expression like adding, subtracting, so that we add have created the different expression for it. Here you can see with the first I have defined one numerical expression and then added add expression, subtract expression. So consider I have this expression need to represent. So with that purpose, we have first put add expression because we want to perform add first, and then later on subtracts. That's is a simple representation for it, which is very useful to understand whenever we want to understand or interpret this expression. It is very helpful, but it make it difficult in case we want to expand this for a large scale, because here what we are trying to do, we are creating the separate object for a small expression, which is going to be very difficult if we have very large number of calculation and we want to perform so many mathematical operations. So it will consume so much memory. So hence it is very rarely used. If you have small object to handle, then only suggested to use it. So if I run it, it will simply do first addition, which is 8, and then subtract with 2. It will get the result. Let's understand each type of behavior design pattern in one line. First, chain of responsibility. Pass request along handlers until one handles it. Here, object passes a request to another object until one object handles a request. Second, commands converts the request action into an object. So here the instruction is given to the object. Object perform logical operation based on instruction. It perform undo and redo operation. Third, iterator traverse element without exposing structure. We have seen in the list structure where we have traverse element from the list without exposing the list. Fourth, mediator centralized communication between object. We can understand with the example of chat room groups, where we have defined the groups and everyone pasted their message into the chat and other people get notified. Fifth one, Memento, save and restore object state. It is very much similar to the command, but it is used for the destructive operation. In case of restore from to the versioning of the previous state of the files, we can utilize this Memento. Six is observer, notify multiple object when state change. It is very much similar to the publish subscriber, where one published a message and many subscribers get notified to the message. Seventh one, state change behavior based on internal state. We have seen in the ATM machine example where single yes button, it operate differently in a different state. Eighth strategy, switch between different algorithm dynamically. We have seen in the payment method where we have multiple payment method like payment through card, payment through API, and we can easily switch between different payment method using this design pattern. Ninth, template method, define flow, allow step to vary. We have defined all the flow at the parent class and we allow to modify it from the child class. 10th one, visitor, add new operation without modifying object. It is very much similar to the open close principle, where open for extension and close for modification. We have seen in the liquor and necessity item implemented with different texts. So we have created a separate class for the texting. 11th one, interpreter. Evaluate language or expression. We can understand this one with the tree like example where we have defined the expression for adding number at the root, and at the branches we have another classes which provide the number input, and whenever we call this expression it will call the branch and bring the number and perform the operation and give the result. This interpreter is very much memory consuming, so hence it's not recommended when we are performing the large operations. Thank you.